We're talking about enterprise applications here where there is going to be state involved. Now, in my mind, state falls in 3 buckets. Bucket 1 is your business backend databases. This is your core database that your enterprise relies on. There's another bucket, which is your data lake, so to speak, where you have a large amount of data, potentially unstructured documents or semi-structured documents. There's a third area for cloud-native applications where state plays a big role. These are more of your nearline databases, things like message queues like Kafka. These could be NoSQL databases like Mongo or Cassandra, or maybe SQL databases like Postgres, and then certainly things like Elasticsearch. This area is characterized by having a large number of databases, many instances of these databases. Typically, these databases are small, a few hundred gigabytes at best. The more you're developing your application and adding features to it, you're potentially changing what your data structures look like. Take an application like Cassandra or Kafka or MongoDB, distributed databases. Kubernetes will do a great job in scheduling the application, but who's providing the actual physical storage? So all the way from provisioning to then managing the availability of it or the durability of it. What happens if a disk fails? Or what happens if Kubernetes wants to try and rebalance that application and bring up the containers on different machines? Will it have the data that it needs at the time that that container comes up? You're not running 1 or 2 or 3 containers on a node. You're running hundreds of containers on a node. So how do I provision that many volumes for these containers? What about the availability if a node goes down and the containers need to come up on different machines? Are those storage volumes going to be available? What about the backup of those application containers? And the scenarios get more complex because these are distributed applications, meaning if you deploy Cassandra, you're easily running a handful of containers on different nodes. Portworx solves a couple of different things for not just EKS, but Kubernetes in general, which is bringing storage intelligence into Kubernetes. Portworx allows for EKS to efficiently manage stateful applications, number one, by way of taking advantage of all of the automation and provisioning and HA functionality built into Portworx for Kubernetes, but also number two, allowing for EKS to programmatically control how Amazon's physical infrastructure is allocated and managed.
Amazon EKS and Portworx works hand in hand, which actually gives you a better flexibility and reliability of the storage that is required to run any of your stateful workloads. And also it enables you to have a disaster recovery at the storage layer.
A very large-scale telecom provider has been using Portworx to build a data-as-a-service platform to enable at-scale log analytics for their applications. Portworx is being used with open-source Elasticsearch to replace Splunk in the customer environment. With Portworx, the customer has been able to increase their ingestion rate 3x and ingest multi-petabytes of data into their Elasticsearch clusters. Not just that, with Portworx on top of Amazon EBS, the customer has been able to use data tiering by using Portworx on top of various classes of Amazon EBS to provide hot, warm, and cold tiers for different data retention capabilities.